Next problem. In problem 3, we are going to discuss a cantilever load along in which is carrying a UDL along with the point load. So let us see the question first. A cantilever of 2 meter length of the cantilever is 2 meters, carries UDL of 15 kilonewton. UDL is given as 15 kilonewton. Actually, it should be given as 15 kilonewton per meter because it should be multiplied with meters. 15 kilonewton per meter run over whole length. So it is running for a whole length of the cantilever. Let us draw the diagram. What is cantilever first? Cantilever is a beam which is having one side fixed, other side free. So I have drawn the free side. So what is the length of this beam? Length of this beam, complete length is nothing but 2 meters. Length of this is 2 meters. Here it is given. Next, it is carrying UDL for whole length they are saying. So we will draw for whole length. Drawn for whole length. So what is the unit? Here they have given 15 kilonewton per meter. 15 kilonewton per meter. Okay, 15 kilonewton per meter. Next they are given is 2 kilonewton point load at a distance of 0.5 from free end. Which is free end? This is your free end. From free end at a distance of 0.5 meters, 0.5 meters, 0.5 meters, a point load is acting. A point load is acting. Whose unit is 2 kilonewton. Whose unit is 2 kilonewton. Correct? So diagram has been completed. So for drawing the shear force diagram, let us extend these lines. Let us extend the point where the loads is fed. Okay, so how to solve this type of problem is, first thing, whenever you see the cantilever beam or whatever beam you see, first thing you have to write is beam is under equilibrium. Beam is under equilibrium. So what is equilibrium condition? Summation of horizontal force is equal to 0, summation of vertical force is equal to 0, summation of moment is equal to 0. So obviously you know, whenever fixed beam is there, we will have two reactions. One is vertical reaction, another is horizontal reaction at fixed end. But the summation of horizontal forces is 0. No load is acting in horizontal direction. So horizontal direction are having no load means RH will become equal to 0. Well, this condition is solved. Next we will solve this condition. So when we solve this condition, we can see that upward forces should be equal to downward forces. Upward forces should be equal to downward forces. Downward forces. What is upward force here? We are acting reaction force at point A, that is RB, is equal to, here we are having two type of loads. One is UDL, another is point load. How to convert the UDL into complete load? Because the load here is given as Newton per meter. Newton per meter. Simply you have to multiply with the length of UDL. To what length the UDL is distributed here? For a length of 2 meters. So load due to UDL, you can write here load due to UDL. For understanding purpose, you can write load due to UDL. So 15 is length given in meters into meters. This is your length. This is your length. Plus a point load is acting downward, whose value is given as 2. So the total is nothing but 32 kilonewtons. If it is confusing here, we can write is equal to 32 kilonewtons. You got the value of RB. That is equal to RB is equal to 32 kilonewtons. Done. Solve it here. As soon as you complete this, you write the sign convention. You write the sign convention. What is sign convention? Here you have to take, since you are writing from solving from right to left, you have to take downward force. Downward force is equal to positive. Downward force should be taken as positive. Next is anti-clockwise movement. Anti-clockwise movement is equal to, some people call it as anti-clockwise, some people call it as counter-clockwise. CCW, both are same. Anti-clockwise or counter-clockwise, both are same. Should be considered as positive. Okay, done. Next we will solve for shear force diagram. So I will write here shear force calculation. What will write? We will write shear force calculation. So when I do shear force calculation, from where we are starting? Right to left. Right to left. Right to left means, let us give the name to this. So this is point A. The point acting at point load is B, and this point is C. So what is the extreme point to your right is C point. So what we have to take? Shear force before C. Shear force before C. There is no load acting right side to C point. So the load will be, shear force will be equal to 0. Force is equal to 0. Next, shear force at point C. Again, even though the load acting at point C, you have a point load, but distance at that point is 0. So again, shear force at point C will become 0. Clear? The next is shear force before point C, before point B, before point B. So before point B means you have to consider the all loads before point B. Before point B, you have UDL. What is the length? What is the value of UDL? Is 15 kilonewton. But before B, to what length the UDL is distributed? 0.5. So we have to multiply only with 0.5. We should not multiply with 2 length. Before means before B point, to what length it is present, we should multiply with only that length. Then only we will get the value of this. Clear? So the value is around 7.5 kilonewton. 7.5 kilonewton. Next is shear force at point B. At point B, along with UDL, you are having a point load. You are having a point load. So 7.5 plus 2. 7.5 plus 2. You will get it as 9.5 kilonewton. 9.5 kilonewton. Next is shear force before point A. Before point A. Before point A means you have to take all the loads right side to your point A. Right side to point A, you are having a whole UDL. You are having whole UDL. So what is the length for which that UDL is present? Right side to A is 2 meters. So here it is 0.5. Why means before point A it is only for a length of 0.5. But whereas before point A it is for a complete length of 2 meters. Okay. So I am taking 2 meters. Along with that, there is another load acting. 2 Newton is acting downwards. That is plus 2. We will get it as 15 into 2, 30. 30 plus 2 is 32. 32 kilonewton. 32 kilonewton. Okay. Next, see here. Shear force at point A is equal to. At point A is equal to. Here, see this. Already to point before point A, the load is 32. All the loads are acting in downward direction, but this load is acting in upward direction. So 32 minus 32. So the total is 0. What God told in the last problem, the initial value and the final value should be 0. With this only you can understand that we have done the right way. If not, we have done some mistake in calculations. Okay. So let us draw the diagram. Let us draw the diagram. So we will take some part, because this is 32. It needs some more length. So we will take it to somewhat downward. Okay. So let us see the values. Initial value is 0. Next value is 0. Done. 0, 0. Both are at the same point. Next value. Come to this point. What is this value? 7.5. So we will keep on 7.5. Okay. After 7.5, again we are getting 9.5. This 9.5 is coming because of point load. That is coming exactly at point B. That too it is acting in downward means it should be taken positive. Positive means you have to rise up. You have to rise up. So this is your 9.5. This is your 7.5. Done. So from this 9.5, if you see what is the last value you are getting, it is 32. So I will draw from 32 to. Okay. So why this inclined line is because of UDL. Again here also what is the type of load acting here? UDL. What should be the line? Inclined. So why this is vertical line is because of point load. That is the reason every time you should solve as before point at point. Before point at point. If you don't follow this rule, you have chances of making mistake at this point. You will have a chances of making a mistake at the point where both UDL and point load will be coming together. So this is your SFD diagram which is in positive. The length of this is your 32. The length of this is your 2 units. How to check your problem is writing this unit same. This 32, this 32 same. And all problem is on the right side. This is your baseline. This is your baseline. So with this we completed shear force diagram. Okay. We solve for bending moment calculation. We will solve for bending moment calculation. Always we are solving from right to left and keep on remembering this so that you can remember the sign convention. Yes. If you do a mistake in sign convention, your whole problem will be varied and changed. Let us solve bending moment at point. First point is the rightest corner to your beam is C point. At rightest corner is C point. C point. So bending moment at point C is equal to before point C there is no load. There is no load. Hence the moment will be equal to 0. Next is you have to take bending moment at point B. At point B is equal to. So before point B, what is the load you are having is UDL load having. So UDL can be converted into load as 15 into it is for a length of 0.5. This is your load now. This is your load now. Now you have to multiply with distance. So for this particular length, where is the CG present? CG will be obviously present at half of this length. Half of this length means this point. So from CG to this length is nothing but half of 0.5. So I will take it as 0.2 divided by 2. 0.5 divided by 2, that is CG distance from point B. CG distance from point B. Next is bending moment at point A. Bending moment at point A. B is solved. Now we are coming to bending moment at point A. So bending moment at point A can be solved. We will get moments because of two loads. One is UDL, next is point load. So both will be giving you moment. So first let us solve because of UDL. So what is your total length before A point is? It is over for a length of 2 meters. So 15 into 2. This is your load. So what is distance? The distance for this UDL is nothing but for 2 meter length UDL, its CG will be present at half. CG will be present at half. So CG out of 2, the CG will be present at center point, that is 2 by 2, that is nothing but from A point to this CG will be 1. CG will be 1, that is 2 divided by 2. Sine. Okay? Sine is here minus 0. Then, so what will be the value of this? This minus 1.875 kilonewton meter. 875 kilonewton meter. Okay. Next is this also minus 1. We have solved one load and distance. This is distance of CG from point A. Distance of CG of UDL from point A. Done. Plus this is load because this is moment because of UDL. I will write here above it or below it. I will write. So this is moment because of UDL. Because of UDL. Okay. Next we have another moment that is because of point load. So point load value is 2. So that 2 from load 2 to point A distance. From load 2 to point A distance. This is 0.5 means out of this 2 length, if 0.5 is gone, what is this length distance? 1.5. That is 1.5. So what is the value for this? So both are sorry. This is also minus. This is also minus. So both are in clockwise. Both are in clockwise. Sorry. Please keep in concentration of signs. Okay. So minus. So this 2 cancel. This is 30 minus 30 minus. This is 50 into 1.5 into 2 is 3. Total is minus 33 kilonewton meter. Please remember this how I have solved. This is moment due to UDL. This is moment due to point load. Both should be taken. Clear? I am writing this so that you can remember properly. So your value is getting minus 33 kilonewton meter. Let us draw the bending moment diagram. Obviously, you are getting minus 33 maximum. This is minus 1.8. Next is 0. So what I will do is I will take the line to somewhat upside. So this is my baseline. This is my baseline. So when we take the baseline, what is moment at point C is 0. What is moment at point C is 0. Next moment is at point B. At point B it is minus 1.85 minus 1.875 kilonewton meter. Next at point A it is minus 33. Okay, at point I am writing minus 33 kilonewton meter. Now see this, how I have to join? Since here it is acting UDL, the curve will be parabolic. So you have to write it as parabola curve. Okay, you will write as parabolic. Okay. Next is from here to here also you are having a UDL length. So this is also a parabolic curve. This is also parabolic. See, even though it seems to be a inclined line, it is not inclined. That's why I am writing parabola. But whereas this is inclined, this is also inclined. You should remember, UDL comes, inclined line comes in shear force diagram. Here it comes parabolic diagram. You may get confused. Sir, here it is point load. Why we are taking parabola means out of this is only acting at a point, but whereas the dominating force is your UDL. So obviously the curve will be parabolic. Okay, obviously the curve will be parabolic because UDL dominates compared to the top point load.